I'm Kushbu Kalyani from the Lightpoint Product Marketing team, and this is my 3 for 3. What is UWB and why is UWB gaining so much attention? So UWB, also known as ultra-wideband, is a short-range wireless communication technology defined in IEEE 802.15.4z standard. This technology is not new and was originally deployed in early 2000s for high data rate transmissions, but for reasons it failed to achieve a mass adoption. However, with the amended IEEE standard, the technology resurfaced, but this time for low data rate, short ranging and positioning applications. Now, despite the presence of some other technologies such as Bluetooth, Zigbee, Wi-Fi, etc., UWB seems to be gaining significant momentum and adoption in consumer electronics, industrial and retail applications because of its unmatched precision, security, speed, and reliability. Now let's understand why. So typically other technologies rely on RSSI or signal strength indicator for ranging. UWB, on the other hand, uses time to determine the distance. It transmits information spread over a channel bandwidth as wide as 500 megahertz, and it uses a series of narrow and steep pulses which are less than 2 nanoseconds, and they travel at the speed of light. This makes the communication extremely secure as time is difficult to fake, and any attempt that is made to intercept the UWB signal will only result in delay of its arrival, thus making the signal look or come from farther than being closer. Furthermore, the narrow pulses makes it possible to mark the signal timing with a high degree of certainty, making it highly accurate and thus enabling real-time tracking or asset control or movement detection of an object. And it also makes it resilient to multipath fading, precisely because the shorter the pulses, the less likely they are to overlap with the reflected signal. And that makes it easier for the receiver to distinguish the signal, the direct signal or the original signal from the reflected signal. When you compare UWB to other technologies such as Wi-Fi or Bluetooth, they deliver accuracy between 2 to 3 meters. UWB delivers accuracy within sub 10 centimeters with a reliability of 99 to 95%, making it suitable for operation in almost all environments. These distinct features of accuracy, security, reliability, resilience to interference, and real-time measurements make UWB an ideal technology for ranging, microlocation, positioning, precision sensing applications, and a lot more. So how does UWB work? UWB uses what is called as a time of flight mechanism to determine the actual physical distance. It is the time, so time of flight is the time that it takes for the signal to travel from the transmitter to the receiver or from one device to another. So whenever UWB capable devices are in the vicinity of one another, they start something called as ranging or exchange of ping pong messages to measure time of flight. Once this measurement is made, the distance is calculated by simply multiplying it with the speed of light. Now, ranging can be either single-sided or it could be two-sided based on whether the device initiating the poll sends another poll message after having received a response to its original ping, So both the initiator or the transmitter and the receiver can compare the test times. Apart from the single-sided or the two-way ranging, another way to implement time of flight is using the time difference of arrival. Now, in this method, there are multiple anchors, or you may call as reference points, that are deployed in an area. So whenever a tag or a mobile device is in the vicinity, the beacons transmitted by it are received by the anchors at different time intervals based on the position or location of the anchors. Now, these beacons, when they're received at the anchor, they are time stamped, and that information is sent back to a central location engine that runs multilateration algorithm to compute the position of the tag or the mobile device. Apart from the position or the distance determination, UWB uses a supplementary method called the angle of arrival, also known as AOA, that can be used to determine the motion or direction of an object. Now, in this case, the receiver or the anchor must have multiple antennas to receive the UWB signal from the moving object. And based on the phase difference of the signal received and the distance between the antennas of the UWB device, you can use triangulation to calculate where the signal is coming from and determine its location based on your direction based on your or the tag's orientation. By combining time of flight and angle of arrival, and you repeating these measurements multiple times, UWB can determine the speed and direction of travel. So what spectrum is used for UWB technology internationally, and what channels are most popular? UWB operates in unlicensed radio spectrum, and the FCC defined frequency range for the technology is 3.1 gigahertz to 10.6 gigahertz, with almost 15 different channels with over 500 megahertz of bandwidth. Now, not all channels are used, and most of the focus is in the frequency range of 6.4 to 10 gigahertz. Now, again, the regulatory guidelines for the technology vary region by region, and the frequency ranges between 6.4 to somewhere around 7.9 gigahertz, especially channel 9, has a wider global acceptance. And this channel is, again, can be used in any region and is not affected by potential interference from other narrowband technologies. There are certain channels though, like channel 5, for example, which is in the center of the 6 gigahertz Wi-Fi spectrum. And so that may be affected by minor packet losses, but again, that is in dense Wi-Fi environments, and that's fairly low. However, FCC limits the transmit power spectral density to minus 41 dBm per megahertz, which makes UWB immune to interference from any underlying narrowband signal that it shares the channel with. With the growing need for microlocation, precision, access control, UWB is being seen as an apt technology for use in applications like asset tracking, inventory management, hands-free mobile payment, gaming applications, keyless access control to personal devices like entry into the car or entry inside your home. And so this technology promises to deliver seamless and more consistent user experience by the virtue of the many features or benefits that it offers in terms of reliability, security, immunity to interference, precision. So I hope this video was informative. Thanks for watching today's 3 for 3 and see you next time.